So we just need p hat, p naught, and of course the sample size n, which we know was 900. And we plug those numbers into this formula to get the test statistic. So that's going to come out to equal 0.0133 minus 0.02, all divided by the square root of 0.02 times 1 minus 0.02, all divided by 900. If you plug all that into your calculator, this ends up giving you approximately rounded, and we're rounding these to 2 decimal places. The reason we're rounding this to 2 decimal places is because, I know it's hard to see on the camera, all these calculations are in the solution key. So if you can't see it on here, just look on your solution key and you'll see it. I showed every calculation. So when you plug into this formula for the test statistic, you plug all the numbers in and hit enter on your calculator, you should get negative 1.44 rounded to 2 decimal places. And the reason why we round these test statistics to 2 decimal places is we're going to treat them as z-scores or standard scores, like from Chapter 8. And remember, all z-scores or standard scores, we always round those to 2 decimal places. Alright, so that's the end of step 3. Take the given statistics and the given P naught from the claim and plug into the test statistic Z. Z naught, actually, they call it Z naught. And Z naught then comes out to be negative 1.44. Alright, now we move on to step 4. We're going to take this Z naught and we're going to look up a table value in table 5 for this Z-score. And then from that, we're going to come up with a p-value for this test. So this is where you have to be careful because the 2 methods branch, the classical approach and the p-value. You want to go to the right and follow the p-value method. Not the classical approach, but the p-value method. So when you get to step 4, it says, find the p-value. Well, you're going to take the Z0 that you got from step 3, which was negative 1.44, treat it like a z-score, and go to your cheat sheet. When you go to your cheat sheet, you're going to flip until you get to the back of the cheat sheet where you have what's called Table 5. Table 5 is very much like the table on page 157 of the book. It enables you to get percentiles from z-scores. So we're going to treat our test statistic from step 3 as a z-score. So you look in the section for negative z-scores. And in that table, on table 5, it's a little different than the one in the book. You have to break it into the first decimal place and the second decimal place. You first look for negative 1.4 in the left column. So you go down until you get to negative 1.4 in the left column, and then you scoot across the top until you get to 0.04. So negative 1.4 along the left column, and then 0.04 along the top row of the table, and then that leads to, if you go to, it leads to a number right below 0.04 in the top row, and right to the right of negative 1.4 in the left column, and that's where you get the table value in table 5, corresponding to z equals negative 1.44. So every table has a different setup, and this table uses the first decimal place of the z-score in the left column of the table, and then the second decimal place runs along the top row. Then you've got to go down the left column to negative 1.4, across the top row of table 5 to 0.04, and then you have to go down from the top row number and to the right of the left column, and then you find a table value in table 5. Ah, man, it's not in here. See how? And if you do that, you go to negative 1.4 in the left column, 0.04 in the top row, and then from that you get the table value in the table. If you look in the table, it should lead to a table value of 0.0749. So you'll get 0.0749 as your table value. So from table 5, using that z-score, our table value came out to be 0.0749. Now we have to decide whether the table value is the p-value or we do 1 minus the table value to get the p-value. And that depended on whether the test was left-tailed test or a right-tailed test. This is step 4. Well, remember, we have a left-tailed test. So when you have a left-tailed test, the table value for the test statistic is the p-value. If you have a right-tailed test, you would have to subtract the table value from 1 to get the p-value. But we have a left-tailed test. So that means the p-value is equal to 0.0749. If it had been a right-tailed test, I'd have to take 1 minus that, which would have led to what? 0.9251. But it's a left-tailed test. When you're left-tailed, the p-value is the table value. When you're right-tailed, the p-value is 1 minus the table value. You just have to remember that. All right, so our p-value in step 4 came to 0.0749. So now let's move to step 5. What does step 5 say under the p-value method in that flow chart on page 545? Well, what it says is, if you read it, you got to flip the page, go to page 546, and it says, if the p-value is less than alpha, reject the null hypothesis. Well, I still have alpha here. Is 0.0749 less than 0.05? If the p-value is less than the given alpha from step 2, it says you reject the null hypothesis. You reject H naught. Well, notice our p-value is not less than the given significance level. 0.0749 is larger than 0.05, not less than 0.05. So what that means is, in step 5, we do not reject H naught. Is that coming up? We do not reject H naught. It says you only reject H naught if the p-value is less than the significance value. If the p-value is not less than the significance level, and it isn't, 0.0749 is not less than 0.05, then we do not reject H naught. So the only possible answers to step 5 are, you either are going to reject H naught or you're not going to reject H naught. And if the p-value is less than alpha, you reject H naught. So if the p-value is not less than alpha, you do not reject H naught. So our answer to step 5 is we do not reject H naught. All right, now let's move on to the very last step, state our conclusion. So just to summarize, because I have a flow chart that I provided, because if you read step 6 on page 546, step 6 just says, now state the conclusion. It doesn't tell you how to state the conclusion in step 6 on page 546. It just says state it. So how do I state the conclusion? Well, I provided on the very last page of the cheat sheet a flow chart that enables you to use the results of the first 5 steps to easily just get to the conclusion. So I added, to make this easier, on the very last page of the cheat sheet, very last page, and it says for last step. So go to last page of cheat sheet. If you look at the last page of the cheat sheet, what it says is, first question in that flowchart says, did the original claim contain the condition of equality? Remember, the claim did not have an equal sign in it. The claim was that P was less than 0.02. Our claims never have equal signs in them in these problems from this book. So in other books, the claim might have an equal sign, but for our purposes, our claims never have an equal sign. So we always get a no for that first question. And then after you follow the line for no, the claim did not contain the condition of equality, you then get to a question that says, did you reject H naught? So the second question has to do with step 5. You either did reject H naught or you didn't. Now in our step 5, we failed to reject H naught. So when it says, did you reject H naught, our answer is no. So no, we did not reject H naught. So since we did not reject H naught, you follow that line and it says, there is not sufficient sample evidence to support the claim. So our final conclusion is, we do not have sufficient evidence at a significance level of 0.05 to support the claim that fewer than 2% of the manufactured products are seriously flawed. So notice that in every test they make a claim about a population percentage. Your conclusion, since we're always going to say no to the first question in the flow chart for the last step, we're always going to end up either concluding that our sample data did support the claim or our sample data does not support the claim. In this particular instance, we ended up saying that the sample evidence does not support the claim that fewer than 2% of the manufactured products are seriously flawed at the significance level of 0.05. And this is all in the in the solution key to the sample practice test. And if you can't read it here, it's all written very clearly in step 6. The way you do it is go to that last page of the cheat sheet, follow the flow chart, answer the yes or no questions based on your responses to the first 5 steps. And that leads you to one of 2 possible answers. You either are going to have sufficient sample evidence to support the claim, or you do not have sufficient evidence to support the claim. In this case, we did not have evidence to support the claim. All right, we're going to do the same kind of thing in problem 10, but instead of testing a population percentage, we're now testing a population mean. So instead of using the flow chart on page 545 and 546, we use the given flow chart in the cheat sheet from pages 520 and 521. So there's another flow chart in the cheat sheet that gives you a 6-step method for testing claims about population means. And that's on page 520 and 521 in the cheat sheet. So if we use that flow chart, let's first read what problem 10 says. So let's go to problem 10 now. Problem 10 says, suppose, and I'm going to write down the given information. The claim says that suppose a certain company that manufactures AA batteries claims that the mean lifetime of a single battery manufactured by their company is greater than 54 hours. I got to write the claim in symbolic language. So I have to write mean, population mean, inequality sign, mu naught for some number. So how do I write that claim in condensed symbolic language where I just say population mean, inequality sign, some number, mu naught? Well, it says, suppose a certain company that manufactures AA batteries claims that the mean lifetime of a single battery manufactured by that company is greater than 54 hours. Greater is a greater than sign. So we're claiming the mean lifetime of a single AA battery is greater than 54 hours. So our mu naught is 54. So in symbolic language, the claim is just mu greater than 54, or mean greater than 54 hours. So what that means is the counterclaim, if the mean is not greater than 54 hours, what's the only other possibility? That's the counterclaim. That in symbolic language would then be mu is less than or equal to 54 hours. So either mu is greater than 54 hours, the claim, or what? Mu is less than or equal to 54 hours, and that's the counterclaim. Now I got to write one of these as H1 and one of these as H0. Remember, the counterclaim becomes the null hypothesis. It's the one